here is another way to solve a system of equations, and it's called elimination. So what you want to do in this case is you're going to eliminate one of the variables. So it's great for a problem like number 1, where we see we have two opposite variables. We have a plus 3y and a minus 3y. So if I simply add these two equations together, 2x plus 2x becomes 4x. Positive 3y minus 3y cancels each other out. 5 plus 7 becomes 12. Dividing both sides by 4, we simply get that x equals 3. Way easier to do when problems are in this format. So same as before, when x equals 3, we just plug it into one of these equations to find out what y is. So I'm going to plug it into the first equation, 2 times 3, because that's what we just got for x. So we're going to plug that in for our x, plus 3y equals 5. So we get 6 plus 3y equals 5. I'm going to subtract 6 from each side. So you get 3y equals negative 1. Divide by 3, divide by 3. So you're left with y equals negative 1/3. So y equals negative 1/3, x equals 3. Let's go ahead and plug that in just to make sure that it works. So let's plug it into the bottom equation. So x is 3. Oh, let me change the color. X is 3, and y is negative 1/3. So 2 times 3 is 6, minus 3 times negative 1/3 becomes plus 1. 6 plus 1 is 7. Yay! It worked. Okay, so now let's apply that same strategy to number 2. If we add these equations, we're going to be left with 6x minus 3y equals negative 12. So we added them, but nothing was eliminated because our x's were the same sign. So we can change that. If we changed one of our equations, so if I made this a negative 3x, a positive 2y, and a positive 7, so I changed the sign of every single term, and then add it together, my x's will now cancel out, leaving me with negative y plus 2y is y. Negative 5 plus 7 is 2. So you get an answer of y equals 2. We're going to plug that into our equation. I'm going to plug it into this y right up here. So I get 3x minus 2, because that's what y is, equals negative 5. I'm going to add 2 to each side. So you get 3x equals negative 3. So x equals negative 1. X equals negative 1. Y equals 2. Let's check that one. So let's plug it in right here. So x is negative 1 and y is 2. 3 times negative 1 is negative 3. Oh, negative 3 times negative 1 is going to be positive 3. 2 times 2 is 4. So 3 plus 4 equals 7. It worked. Okay, be sure you have all of this written down in your notes, and let's put a little note here. Multiply by negative 1 to change the signs. So that's what we did here, here, and here. Okay, pause the video. Make sure you have all of this written down in your notes. Okay, so now here we have 2 more examples. So we can tell if we just add these, we're going to get 7x negative 8y. So neither one is dropping out. So that tells us we need to multiply or divide by a negative 1. So I'm going to change all my signs on the bottom. Doesn't matter which one. Change, change. Now when I add them, 3x, my y's are going to drop out, and I'm left with negative 6. 3x equals negative 6, so x equals negative 2. I'm going to plug that back into my top equation. 5 times negative 2 minus 4y equals negative 10. Negative 10 minus 4y equals negative 10. When I add 10 to each side, I get negative 4y equals 0, so y equals 0. And x equals negative 2. Let's check that really quick. If we plug it into the bottom, negative 2 times negative 2 is 4. 4 times 0 is 0, so 4 plus 0 is 4. It worked. Let's look at example number 4. When we add these together, negative x plus x, my x's drop out, y minus y, my y's drop out. I've got 0 left on this side. So we get 0 equals 4. So that is a false statement. So because this is false, it tells us it's a no solution.